Hello grade 12s, welcome back again into our video. So today let's look at this question. Okay, let's try to solve this question. So the very first question says, given the pattern 1, 4, 16, 64, 256 until 65,536. So the sequence ends there, okay? I repeat, the sequence ends there, meaning that 65,536 is our last term. The very first question says, calculate the value of term 7. Let's calculate the value of term 7. So meaning that we have to identify which kind of pattern is this one. The type of pattern is a geometric sequence, because in order for us to get the next following term, if we can look though roughly, we can clearly see that we have to multiply by a constant ratio which is equals to 4. 1 multiplied by 4, 4 multiplied by 4, 16 multiplied by 4, 64 multiplied by 4, 256, and. Okay? Alright. Let's calculate the value of term 7. So for, okay, let's just say 1.1 here. So let's say Tn is AR to the power of 10 minus 1. So our T7 will be equal to, what's A? A is 1 multiplied by 4, which is the ratio, to the power of n minus 1. So looking for 7, for term 7, our term 7 will be equal to, 1 multiplied by 4 to the power of 7 minus 1. And therefore, our term 7 will be equal to, you can press on a calculator, so you can clearly just say 4 to the power of 6, because 1 multiplied by this will be also give you the very same thing. Okay, so 1 multiplied by 4 to the power of 7 minus 6, so to the power of 6. Okay, so 4096. So our answer there is 4096. 4096. That's it. That's our term. That's our term 7. Okay, that's the answer. All right, let's move to 1.2. All right, so let's move to 1.2. 1.2 says how many terms are there in the sequence or in the pattern. All right, so I told you that this is the last term, so meaning that we're just going to simply say Tn is equal to AR to the power of n minus 1. So the last term, looking for n, right, for T something, so that you can know that our terms in the sequence are this number. Okay, so Tn, the last term. Okay, so 65,536 is going to be equal to, what's our A? Our A is 4, no, our A is 1. Okay, let's just move that. Our A is 1 multiplied by 4 to the power of n, okay, minus 1. We're looking for n, okay? We don't know what we're looking for, okay? Yes, looking for n. All right, so what are we going to do here? We're going to say 65,536 is equal to 1 multiplied by this, so that's going to be it, okay? N minus 1. The simple thing is that you can just change this to become an exponent so that you can solve the problem. You can be able to solve for or to find n. Right? So you can just press on the calculator. 65,536 is equal to shift fact. Okay, so it gives you 2 to the power of 16. Maybe some of you might have known that, okay? But now we want the base to be 4. So that's going to be let's say 4 to the power of 8. Okay? Yes. It gives us the very same thing, because if also when you calculate it gives you 2 to the power of 16, so let's multiply the base by 2, that's going to be 4. And let's divide the exponent or the power, also the power by 2, so that's going to be 8. So 4 to the power of 8 is going to be equal to that. Okay, yes. Also if I can press 4 to the power of 8, it's going to give you 65,536. So that's going to be 4 to the power of 8 is equal to 4 to the power of n minus 1. So let's bring down so that we can solve for x. Let's bring down powers. So we have 8 is equal to n minus 1. And therefore, our n will be equal to, 9. So mean that we have 9 terms in that sequence. Okay? Yes. So we have 9 terms up until 65,436. So 65,436 is term number 9. You can check that by substituting the calculator and substitute 9 there. You can just clearly have that. So let's say to the power of 9 minus 1. So it's going to give you the very same thing, which is 65,536. And that's how it goes. Alright. Let's move to the last question. So the last question says, is 4,194,304 a term in this sequence? Is this a term in this sequence? Let's check by calculations. Okay, I'm running out of space right now. Let me just erase that. You can just pause and look at that. I'm just going to erase this right now very quick. Alright, so let's move to number 3. Alright, so let's move to number 3. So let's move to number 3. Alright, so is, okay, Tn is equal to 1 multiplied by 4 to the power of n minus 1. Alright, look. Let's take this as Tn, so it's going to be 4,184,304 is equal to 1 multiplied by 4 to the power of n minus 1. Alright, so look, let's change this to become a base of 4, okay? Because this 1 multiplied by 4 to the power of n minus 1 is going to be the very same thing as this 4 to the power of n minus 1. Alright, so let's check. If you press shift fact, I think it's going to give you 2 to the power of something again. Okay, so let's say, so on this side we're going to have 4 to the power of n minus 1. On this side we have to change this to become an exponent so that you can be able to solve for n, right? So I think that is going to be 4 to the power of say of 11. Okay. Yes. 4,194,304. It's 4 to the power of 11. Okay. 4 to the power of 11, and therefore our 11 will be equal to n minus 1. Take the powers down. Okay, so that you can solve for n. Okay. So and therefore our n will be equal to 12, right? Yes, because this one is going to be go to that side and change the sign to be plus, so 11 plus 1 is 12. That's how it goes. And that's it, guys. And that's the end of our lesson video. Don't forget to subscribe for more tutorials. Have a good day. Cheers.